We have already learned the nodal analysis technique. In the nodal analysis technique, we use Kirchhoff's current law, and in the mesh analysis technique, we use Kirchhoff's voltage law. We shall focus more detail on this mesh analysis in this session. The mesh analysis is as powerful as node analysis, but sometimes we use mesh analysis if the number of branches are connected in series. And then there is a small difference between a loop and a mesh. Let us see what it is. A loop is any closed path in a circuit. So, for instance, if there is a possibility of many loops, then we shall define what a mesh is. The mesh is a loop again, but it will not contain any other loops within it. So, you get exclusive meshes. For instance, in a particular circuit, there may be 4 loops or 5 loops, but the meshes are limited. The meshes may be just 3 only. So, you have to find out the difference between a loop and a mesh. So, we shall write the mesh analysis equation using Kirchhoff's voltage law, and we shall explain the mesh analysis using 3 steps, just like we have used 3 steps in the analysis of a node, analysis of a problem using node. We have seen in the node analysis that there are 3 steps for the solution. In the mesh analysis also we have 3 steps for the solution. The first step is to identify the mesh current, just like in the node analysis we have identified the nodes. Here we identify the mesh currents, and the next step is applying the Kirchhoff's voltage law, and we use the Ohm's law to express voltages in terms of the currents. And the third step is we get simultaneous equations. If there are n meshes, we have n simultaneous equations, and then we have to solve that n simultaneous equations. To illustrate the mesh analysis, we shall take a very small example consisting of 2 sources and 3 resistances. The problem is to find out the currents in this branch, current in this branch, and current in this branch. So, we use the mesh analysis. How to do it? We use the Kirchhoff's voltage law for the first loop. We identify one loop here, we identify the second loop here, and we apply Kirchhoff's voltage law in this loop and Kirchhoff's voltage law in the second loop. Kirchhoff's voltage law says the sum of the voltage rises equal to sum of the voltage drops. For instance, if you start here, this is the voltage rise, there is a drop in the resistance, there is a drop in the resistance, there is a drop because we are going from plus to minus, there is a drop in the voltage source. That is why if there is a rise, we will put minus, if there is a drop, we will put with a plus. So, we have Kirchhoff's voltage law for the first loop as minus 15 plus 5 I1 plus 10 into I1 minus I2 plus 10 volts. So, that is the, we have to be careful about this, 10 into I1 minus I2, that is the drop here. We have to consider the next loop current also. For the second loop, what are the voltage rises? There is one voltage rise, the rest are drops. And what is the voltage rise? Voltage rise is minus 10 volts because it is a rise, we are putting it as minus 10. And then here there is an interaction of the first current and the second current, I2 minus I1. 10 into I2 minus I1 is the drop here. I2 into 6 ohms is the drop across the 6 ohms resistance. Same I2 into 4 ohms is the drop across the 4 ohms resistance. So, we have written Kirchhoff's voltage law for the first loop and Kirchhoff's voltage law for the second loop. So, therefore, we have 2 equations and 2 unknowns are there. One unknown is I1 and the second unknown is I2. So, we solve this simultaneously. So, we get I1 equal to 1 ampere, I2 equal to 1 ampere. How to find out the branch current? The loop current is the branch current in this as far as this resistance is concerned. That is why I1, the branch current is the same as the loop current I1. So, we have 1 ampere. I2 is also like that. I2 is the loop current and branch currents is one and the same. We have 1 ampere. What about I3? In I3 we have the equation. I3 is I1 minus I2. Therefore, I1 is 1 ampere, I2 is also 1 ampere, so no current flows in this. So this is the solution. If we get I1 and I2, we have everything. Let us see a small example to find out the various currents by loop method. So we shall identify the number of loops here. There are 3 loops. One is this loop, second is this loop, and the third is this loop. Solution of this problem we will get it if we are able to find out the 3 currents I1, I2 and I3. That means we will write 3 equations, Kirchhoff's voltage equations for all the 3 currents. So for instance, in the first loop, there is a voltage rise. That is why we have put it as minus 24. There is a rise here, minus to plus, it is going up, minus. And then there are 2 drops. One drop is here, 10 into I1 minus I2. The second drop is 12 into I1 minus I3. So likewise, we write the equations for I2. Let us see the equation for I3. How to write that? I3 equation is, there is a drop here, 4I0 is the drop, dependent source drop. We have taken as if it is a voltage source. Then 12 into I3 minus I1 is the drop here. 4 into I3 minus I2 is the drop here. So the third equation is this. What about I0? I0 is the current flowing here. How much is the current flowing? The current I1 is flowing in the same direction as I1. Current I2 is flowing opposite to that one. Therefore, I0 equal to I1 minus I2. So we have sufficient number of equations. If we simultaneously solve these equations, then we have the currents solution for I1, I2 and 3, and other voltages, branch voltage, etc. we can find out with the Ohm's law like this. For instance, the drop across this is the current 12 into I1 minus I3. So that is the drop here. So we found out the solution for this particular problem.